Blue Falcon, aka Matt Podwysocki, aka Lambda Calrissian, back with you for yet another of our introduction to RxJS. Note today I'm just a little short-handed. I don't have my fancy setup today, so instead I've got these cheap little headphones that I'm using so far. So, where are we nowadays? Well, let's go over where we've been. So we've gone from the beginning of creating an observable and then done sequences over time, which once again was more about the schedulers. We had creating observables the easy way. Then we had creating delayed and polling operations, which is using a timer and interval. Then we had converting our given data structures such as arrays, maps, sets, generators, etc. to observables via from, as well as some other operators there. But that's the biggest one that you'll find the biggest bang for your buck there. Then we covered moving events over to observables, which once again is one of the bread and butter pieces of RxJS, in that what we originally called Rx way back in the day, before it had its name of Rx, which was link to events, and link to events, link meaning language integrated query. So we had link to events, and that was how we got started and how we originally started promoting Rx, which was pretty much right over events. And the reason why, just to give you kind of a history, in most languages that events are not first-class objects. In fact, they're just callback handlers and so forth. So they're obviously not compositional in any shape or form. And the Volta project, which this was all born from, that wanted to be able to do tier splitting of your applications so that you could process one particular piece in .NET, you could tier split to another part in JavaScript, and so on and so forth, so that you could send literally your mouse movements from your front end to your back end using the same data structure. And since there was no such data structure, we're talking the days before tasks in .NET, and we're talking about before promises were really a thing in JavaScript, and instead we had callbacks. So we unified on this single object, observable, and boom, the rest is kind of history. But like I said, is that its very roots were based on events. So now enough of that side lesson there. Then we moved on to how we compose together our operators, and that was fairly important in that in previous editions we would simply dot into our next operator that we wanted to use, whether it was map, then filter, then scan, or debounce, or what have you. The problem with that obviously being is that if you're not using all of the operators there, you've got a lot of wasted space in terms of your JavaScript bundle, as tree shaking wasn't really a thing back then, or really wasn't a thing that we could do fairly well. And instead, we made it a little bit more explicit in such a way that you could bring in only the operators that you absolutely wanted, in that you can say, okay, give me map and filter and scan, or map and filter into bounce time, any number of those things, as well as of and from as the creation operators. That was all nicely possible by doing this particular way of what we called lettable operators at the time, and now called pipe operators. Before that, we also had a way of just monkey patching on operators as you wanted them through this add mechanism, but once again, I think it was a lot easier just to go with a simple solution, which is to have everyone export their operator as is. Therefore, no more dot notation, chaining, more than it was for, say, .pipe and .subscribe, and that was about it. Then we got into the mapping and filtering aspect, which is to take our particular sequences and perform some sort of streaming operation on them, whether it was map or filter. And the approach that we've always taken with Rx in particular is, if you know how to program on pool-based collections, whether it's an array or a map or a set or an enumerable or iterable of some sort, then you knew how to program with Rx. Just the only difference being is that it's a push collection instead of a pull collection. So that was all well and good there in terms of trying to understand that we can do these streaming then operations lazily over our observables, such as taking, for example, performing a map, which is to take, say, mouse event args and move them or transform them into just nothing but x and y coordinates of where your mouse happens to be. The same thing applies with filter. It's just a streaming filtering operation, which will only yield the values where the predicate returns truthy. So it could be a true-false thing. It could be something that's truth-y, which in JavaScript is quite a big table of truthy values there. So it's any number of those things that are truthy that can be put into there. Then we went into more of the really handy things with Rx outside of events and so forth. Is the idea that Rx can really be used as a state machine, and why that's interesting is that so think of your Rx stream as a data flow. Or as your shopping cart, and that you can send messages to it and set a new state as time goes along. That's introduced through a concept called scan, and scan gives us the ability to accumulate values over time, so we can emit values over time instead of just plain old reduce, which only emits the single value. We happen to stream out every single time a state change happens, and why that's useful is when we came up with implementing Redux, a fairly popular state management library. But before we got there, we looked at prepending and appending data onto our sequences. So for example, if we wanted to start out our sequence with some default data, we can do that via start with. If we want to end our sequence with some additional data, we can do that with end with. And if our sequence is empty altogether, then we can fill it out with a default value called default if empty. So that's also fairly good to know. Then we did cover subjects, and the idea behind subjects is that they are both not only the observable part of the streaming of data, but they are also a producer of data, in that you can explicitly call next, error, and complete on them directly. And why that's useful is if you're bridging an API and so on and so forth, where such as WebSockets that might be two-way, as well as any particular state management container that you happen to be wanting to implement. Subjects are very, very useful for modeling those kinds of interactions. We have a number of subjects that are out there, including the plain old subject, which is just this notion of this container where you can next to it and you can subscribe to it. The problem, of course, being that these particular data structures are considered what we call hot, which is if you're not listening to them, the data goes by and you'll never see it again. And that's certainly could be problematic when you create a subject and you start emitting data to it and nobody's listening, and at the time, and all of that data is now completely lost. We got around that by adding the replay subject, and then the replay subject allows us to control how far back in time we wanted to view that particular data, as well as how many. For example, if I only want to capture 500 events in our buffer for everyone to share, so be it. Then we also had the async subject, which is a way of freezing an asynchronous value in time, so that if you have a particularly intensive asynchronous operation, you only want to do it once and share the value everywhere, you can use the async subject for that. Then moving on, we had the behavior subject, and the behavior subject is a subject that starts off with an initial value. So if you had, for example, a shopping cart with data, it would certainly have some certain information up front, and you can model it using the behavior subject. And then we went as far as to re-implementing Redux, which is a popular state container library, with using nothing but plain old vanilla RxJS. There was really nothing special that we had to do in order to make this happen. It just kind of worked, where we used all the knowledge that we had so far, which was the subjects and scan and so forth. Now, what we started to do over the past couple of days are to combine sequences. So a lot of the last time that we streamed here, we talked more about the zip and combine and so on and so forth, but we have a number of ways of combining data structures as they come through. So the first part was with zip, and with zip, it basically takes together these two sequences that are kind of index based or in place, and merges them all together as time goes along. So if you have one of 1, 2, 3, and 4, 5, 6, by default it will yield you an array of those two values at those indexes as they go along. And I kind of show you how to do that with iterables, and so it kind of gives you an idea of how we can write a zip on our own. And of course you can do this on arrays as well, but noticing that of course both of these sequences have to be the same length, or else it's just not going to work. So we would either go short on the shorter one and truncate off of any ones that are longer on the other side. Instead of dealing with zip, which is perfectly synchronous in terms of expecting both of them to be at the same time, combine latest was more of a way that we could express that values do in fact change over time in any of these observables independently, as long as each has emitted a value in the first place. So, for example, here we could take things that increment at 3 different times and pipe them through to say whether they're the first, second, or third item, and then we can take items from there. And then we can combine the latest, and what happens is that the time that the first and the second value actually receive a value, the third sequence has already gone on to its second value. So once again, like I said, all of them have to have a value, or at least an initial value, and then as time goes on, those values can change. So for example here, the second one is slowing us down because it's the one that happens to be the slowest in terms of iterating new values. And so what you see is 0, 0, 0, 1, 1, and then 2. And since this one terminates, and they've all they've all given their third item, then the sequence ends there. Now, thirdly, we did the with latest from, and with latest from was not part of one of the original operators as part of Rx, but it came very useful over time. Once again, Andre Staltz, who he invented CycleJS and was a very early contributor to Rx and its success. He came up with this with latest from. Now, how that differs from every other operator is that it combines the source observable with the other values that are calculated of each only when the source emits. So when the source emits, then the other it will grab the latest value of the other sequences in the observable chain once it's ready to go. So I hope now you have a basic understanding of those kind of ways of combining sequences. Now we're going to go a little bit further from what we did there to using concat and merge, because we're going to go even further than that today. So here we had in day 14, which was Friday, which we didn't cover, which was combining sequences with concat. And that is to say that one sequence ends, then the other one's appended onto it, and the other's appended onto it, and so on and so forth. So that's kind of cool, is that if you've got finite sequences that you want to concatenate together, one onto the end of the other, then you can use concat. How useful is it? It's pretty useful when you've got finite data, like I said, and if you need it in a particular order. But when we're talking about streaming data, of course, that can be fairly problematic. Just because, like I said, is mouse movements and other things, other streams of data happen to be fairly infinite. So to combine those using concat is kind of problematic. So instead, you'd want to look at something a little bit more concurrent for your appending needs. So if you wanted to, instead of just using concat, what we have is an idea of merge, and merge has a number of different overloads, which makes it fairly interesting. In that you can just merge together random observables, and they can interleave as they need to. Otherwise, you can specify the amount of concurrency that you have while they're all merging together. So this is fairly useful, for example, if you only want 2 or 3 or 4 of these particular observables to merge at a time. And in fact, what we could do is we could write concat the way we did in the first exercise as a merge with a concurrency of 1, meaning that only one observable is allowed to be subscribed to at once. Pretty cool. The other aspect, of course, since we're controlling concurrency and everything else, we also give the ability to throw in a scheduler. It's more of an advanced use case and more for testing purposes, but like I said, is that we give you the ultimate flexibility for that foot gun that you want. So we can show you here using our interval and our examples from last time, then to project on forward where each of these values happen to be and how they interleave with one another. For example, the third emits first, followed by the first, followed by the third, and it's kind of a race condition between these two here. But we're doing the best that we can in terms of set intervals and how it's managing its concurrency. But like I said, is you can implement concat using merge, and that's exactly what concat really is. It's just concurrency of 1 here. So let's go and take a look at what we're going to talk about today. So by the way, if you haven't noticed, RxJS.dev is the new home for the API documentation, reference documentation for RxJS. It's the new official home, as it were. Before I was showing you kind of something that was had a weird URL with Firebase. Now we have a pretty cool URL to get started with. So once again, we can hop into our API list, and what are we going to talk about today but concat all. So what does concat all really do? Is it takes converts a higher order observable into first order observable by concatenating all of the inner sequences. So what does that mean exactly? Well, what that means is that we can have an observable of observables, and then we're going to deconstruct it, as it were, or flatten it into a single observable stream. So let's go ahead and look at some code and find out how we can use this. So let's go here. All right. So we will import of right now from RxJS, and then we will import concat all from RxJS/operators. Cool. All right. Now, so like I said, is we're going to create an observable of observables. What exactly does that look like, and why would we do that? So we can either create an observable of observables pretty easily through something like of, for example. So if I just say const nums is equal to of, and what of can be is pretty much any observable, or any value at all. But if we have observable, or we just have of 1, 2, 3, of 4, 5, 6, and of 7, 8, and 9. Cool. All right, so now we have our observable of observables. And like I said, why that's useful is that there are a lot of times when we want to call one particular collection and get yet another collection, and calling map on that doesn't necessarily do anything useful for us, because then we have got this multi-dimensional array or multi-dimensional observable, and we would want some way to flatten it down some way, somehow, to make it useful. So why don't we then subscribe to that and see what happens. So, but first we're going to concat all. So const result, this is equal to, we'll take our num, $, and pipe, and concat all. Ta-da! All right, and then we can subscribe to the results. Item console.log next item. Cool. All right, so we can run that by doing our npx ts node of, gosh, we're on 17 already today. 17, so we've got 8 more of these lessons to go, and I hope you're enjoying them so far. So there we're going to run in this all together, and what it's going to do is it's going to flatten all of this into a single observable. So it's take 1, 2, 3, and then followed by 4, 5, 6, then followed by 7, 8, 9. Now that's interesting, but what if we took the previous example that we had here of the first, second, and third from our previous example and wanted to use that instead? And you could do that with concat all if you wanted to. In fact, why not? Because just to show you that that this in fact works, and we will also want to take. And then we will say here, so instead of it being nums, we will have we'll have const nums here, and that's is equal to of num1, num2, and num3. All right. So now we can comment out this. All right. And then we can run this all together. And what will we see? Well, once again, we'll see that each of these is subscribed to in turn with their particular delay. So it's once again running it as fast as it can, but only in the order that it can. So if we then took our nums here that we had, and let's talk about merge all. So going back here to our documentation, we can look at merge all. Now, don't be too afraid that there are a lot of operators, and there largely are. But at the same point, we have a lot of really cool operators that do a lot of good work that you'll need for your particular operation. So merge all is very much like concat all and like merge that we talked about before. But the difference obviously being is that we can control its concurrency here. So once again, we could say it's the concurrency of 1, meaning it's single operation at a time, or it's infinite. Why that's useful is now that we can rip out this concat all, or this concat call that we had in our code, and replace that with merge all. So let's do merge all from RxJS operators, and we'll do that. So when we call merge all together, obviously it's going to let it freely flow as quickly as possible, meaning that the third, then the first, and then the third again, and the second, and so on and so forth on how they emit. But once again, we can set its concurrency here to be whatever we want it to be. So in this case 1, it will go right back to its behavior on concat all. So the next pieces that we'll be getting into, going back here, will be on the merge map and switch map and exhaust map and all the other map functions that you'll notice here. So when you look at merge map to, we have concat map and concat map to, what exactly does that mean? We'll just start to take a look briefly at this, and we won't dive into code just yet, but we will for the next lesson coming tomorrow. The idea, though, is that we can, for every operation that that ends, we can take our inner value that we get. So if we're dealing with an observable of observables, we take in the first value, which is 0, and then we project it to a new new observable, whatever it happens to be, and then we say concat. So it's map, then concat. Since we already covered what map does, then, or concat all rather, so it calls map, then concat all. And in the case of merge map is pretty much the same thing as you would imagine, which is that it's that it goes and merges the values instead of via merge all instead of calling concat all or anything like that. And so merge map is just another name for flat map. At least that's the default mapping that we gave for Rx, because we wanted people that to associate flat map was our general way of combining sequences. And in the .NET version of RX.NET, select many is an implementation of merge map, in that it is select and merge all, or just select and merge in the parlance of Rx there. So we'll talk about these particular cases tomorrow. Like I said, is because we've got a number of maps that are fairly interesting. But these map 2s that we've been seeing here are also interesting, but in the fact that map 2, we can say no matter what value happens to come in, we can always say it's always going to be one particular value. So in this particular case, no matter what document click gives us in terms of event args, the end result will always be high. So that's why we have the merge map 2, concat map 2, and so on and so forth. So I hope you found today useful, and please do follow along and give me feedback. Once again, Bluer Than Blue Falcon on Twitch, on Twitter at Matt Podwysocki, MattPodwysocki, and also follow me on YouTube there as well. So once again, thank you all for coming today, and see you next time. Bye-bye.